Okay, so the next part, we're going to solder stuff onto this board. This is the bottom plate of the hexcopter, and it's got basically a distribution board built into it. What that means is there's going to be direct current that comes in these two tabs here, and it's going to flow out to each of these 6 tabs over here. And those are going to provide power to the ESCs. So we got to solder those all up. The input.
Oh, never mind.
What was the question?
No, I figured it out really easily.
What was your question?
The bottom one has round cutouts, and the top one has
yes.
not round cutouts.
There's the bottom and the top. Yeah. Oh. So maybe Julian, you can help me unpack these. Celebrity appearance.
And what are those ESCs for?
They control the speed of the motor.
Yeah, the ESCs, they unpack this one here. So the direct current comes in. This thing in here has a bunch of transistors in it that slices up the DC current and outputs, and each one of these an alternating current. And the motors, the way these motors work, the way that they're so efficient, they're called three-phase brushless motors. One of the reasons they're so efficient is because they work on this three-phase current. So we're basically just going to have to plug these in. You don't really know which direction it's going to go until you plug it in. So if it goes the wrong way, you flip 2 wires. So a little bit of guess and check that happens there. But that's relatively easy to do. And these are nice wires actually that DJI sells with their ESCs. It's a coaxial braided wire. So the inside here, the red is the power. It's going to have is the positive terminal. It runs on the inside of this wire. And along the outside there's a coaxial core, like it's been braided all the way around, so for the minus side, for the return current. And what's nice about that is as the power demand of this ESC goes up and down, if you didn't create this coaxial cable, you get electromagnetic interference, which would interfere with your compass. It would kind of wig out the compass and make it think that it was pointing in a different direction. So they shield, it basically creates a Faraday cage around the inner core, and it cancels out any EM interference. So that's nice. That's kind of clever. We got to shorten these wires up because they should belong. We have to make this happen. So to do that, pick a length. And the length you pick is going to be how long the red wire or the inside wire is going to be. Here, cut it. Make Rachel squirm. Then give yourself maybe, how does that do here? It's like a 1/2 inch, maybe a little less than 1/2 inch. Work the stripper just through the plastic. You only want to cut through the plastic on the outside and then pull it. And then you find the braided wire on the inside. This is the little coax. This is the ground on the outside here. We're going to want to pull this away so we can get at the red in the middle, the inner wire. And to do that, you unbraid it by just getting your fingernails in it, pulling it apart. So try to get all the wires separated out. Cool. And pull it to one side. Make sure you get all the strands. Twist it up. Nice and tight. And then you can trim it. And then strip the side. Twist it up. Cool. There's a little extra trick that you get to work with when you have bare wire, freshly cut wire. And that is the pre-wetting. So get the solder on the iron, put it on one side of the wire, work some solder into the joint between the wire and the soldering iron. And then once it starts wicking into the rest of the wire, you can start filling the wire up with solder. You want to see it nice and round and shiny. so that you can know that you filled up the entire wire with solder. Same thing for the other side. So prime the iron, put some more in between the iron and the wire. You can see it's starting to wick into the wire. There's this flux material inside of this solder here that lets it flow. Great. Okay, so we got these all unpacked. We're going to do a little bit of soldering. So let's start with this thing here. Plus and minus, very important to get right. So the little red wire in here is going to be plus. We're going to just maybe stretch it out a tiny bit so we don't have to work too hard to solder it down. And we're going to basically try to, one way or another, we're going to try and make these two contacts stick to the pads. Now, to make our lives a little bit easier, I usually try to pre-wet both sides with solder. So I'll take the solder
Just be careful with this hand.
and
Stick it back here.
Or just slide this up or something.
just put a little solder down there. Just like that. Cool. Now these parts come with solder on it already, so we can just go at it. So these wires are relatively thick. You have to be patient, let the heat flow from the iron into the wire, and then melt the solder. So just in really slow motion with the iron always in contact with the wire as much as possible so that you heat everything up. This one is taking its time. If stuff doesn't move fast enough, at least to your liking, you can put a little bit of solder back on the iron, and that helps the heat flow faster into the wire. See, look at that. Huh. All right, cool. All right, so we got a tiny bit of wire stuck onto the pad with a lot of solder. Looking for a nice round blob that surrounds most of the wire, or at least as much of it as possible. And do the same thing on the other side. I'll prime the iron again and go at it. Wire's starting to get a little hot. Should be able to wiggle it, and it should feel kind of strong, nice and tight. Last thing we do for this is just to insulate it, and we're going to do that with hot glue. So we got our trusty little hot glue gun. Put a little insulation around here, so in case anything accidentally tries to short these two, it won't. Also put a little bit for stress relieving on there, so maybe dump a little hot glue right there. Cool. Just as I finish that up, remember that these end up shipping kind of long, so we'll probably have to come back and make this one shorter. That's okay. Hey, you saw how it works. We're going to do all the rest of these now, and come back when we're done with that.